Okay, class, we've arrived at Chapter 10. And Chapter 10 is our Introduction to Calculus chapter. We're going to start getting you guys ready for next year, all of those of you that plan on moving on to take calculus. Here in 10.1, we're going to start with limits and motion, and specifically start calculating instantaneous velocities and derivatives. So, important section, important chapter, especially if you guys are moving on to take calculus. The first thing that we're going to talk about, average velocity. What is average velocity? It's the change in position divided by the change in time. You are going to see this written mathematically as the velocity average equaling a triangle S divided by triangle T. Now, we don't pronounce it triangle. That triangle is the Greek letter delta that represents or stands for change. And then the S is our position, and our T is time. So S stands for position, T stands for time. So velocity average, change in position divided by change in time. Alright, so in example 1, we have an automobile that travels 120 miles in 2 hours and 30 minutes. What is its average velocity over the entire 2.5 hour time interval? Alright, so let's write out our velocity average. Alright, our change in S, our change in position is 120 miles. Our change in time, now we're going to take 2 hours and 30 minutes and just write it in terms of hours. So that's going to be 2.5 hours. When we divide 120 by 2.5, we are going to get 48 miles per hour. That is our average velocity. Now, notice that average velocity does not tell us how fast the automobile is going at a given moment during the time interval. It could have been going 48 miles per hour at a constant rate, but it also could have been speeding up during that time interval. It could have been slowing down. It could have even stopped momentarily during the trip. So, wouldn't it be nice then if we were able to find instantaneous velocity? So instantaneous velocity is the specific velocity at a point in time. And that is the next problem. That's going to be the next example problem. And in order to find instantaneous velocity, we're going to need calculus.